A rectangular prism is a box. We can use a Kleenex box as an example of a rectangular prism, also known as a right prism. All the sides are rectangles, but not all of the sides have the exact same area, otherwise it would be a cube. With a box of Kleenex, it's pretty clear which side is the bottom. It's going to be this side down here. And we can use where the tissue comes out as a clue to which side would normally be considered the bottom. But I suppose if I had a very small shelf in my bathroom, I might choose to put the box of tissues like this. And now this side is the bottom. If we're asked for the area of the bottom of the box of tissues, then what the answer is will depend on which side is the bottom. And of course, most of the time, in an exam for mathematics, you will be dealing with a box, a rectangular prism, a drawing, and it won't necessarily be something like a box of tissues where you have a clue as to what is the bottom. Usually you get your clue as to which is the bottom from the drawing. In this case, I used red shading to make it even more clear which side is the bottom. This rectangular prism has roughly the same dimensions in centimeters as the box of tissues. 22 centimeter length by 10 centimeter width by 9 centimeter height. This is the same rectangular prism, but it has been oriented differently, so there is a different side on the bottom. And in this case, I have a 9 centimeter length, a 10 centimeter width again, and a 22 centimeter height. So the numbers are the same. If we are asked to find the area of the bottom, we are using the area of a rectangle formula, length times width. So for this rectangular prism, the length is 22, and the width is 10. 22 times 10 is 220, and my unit of measure, because these are in centimeters, will be centimeters squared for area. For this rectangular prism, the area of the bottom is still going to be found with the area of a rectangle formula, length times width, and it will be length of 9 times width of 10, and 9 times 10 is 90. We still have the same unit, centimeters squared. So what the area of the bottom is depends on which side is on the bottom. Now let's look at the volume formula for a rectangular prism. The volume formula is very similar to the area of a rectangular formula. It's length times width, but also times height. If we fill in this formula with this rectangular prism, my L is replaced with 22, my W is replaced by 10, and my H is replaced by 9. 22 times 10 is 220, and 220 times 9 is 1,980. It was centimeters, and this is volume, so the unit will be centimeters cubed. If we fill in the same volume formula for this rectangular prism, we are plugging in the numbers in a different order, but we're going to get the same answer. The length of 9 times the width of 10 times the height of 22. 9 times 10 is 90. And 90 times 22 is 1980. Again, centimeters cubed. So the volume of the rectangular prism will be the same no matter which side is placed on the bottom. Unlike the area of the bottom question, we're getting the same answer. When we look at what volume is, this formula is a clue. It's the same as the area of a rectangular formula, length times width, but also times height. Length times width is the area of the bottom, the red rectangle, and then we multiply it by the height. We can see that as being, what if we put a whole stack of red rectangles, one on top of the other, until it got so high that it was the same height as this rectangular prism. If we did that, we would be filling all the space inside the rectangular prism with flat red rectangles until it was full. And the idea of filling a shape until it is full is what volume is. Same here, the length times width is the area of the red rectangle on the bottom, and if we stacked enough of those all the way up to here, then we would be finding the volume, because all of those red rectangles would be filling up the box. Filling up the box is volume. This means, of course, we don't really have to memorize the volume of a rectangular prism formula. It's not a very difficult formula to remember, but in order to have fewer formulas to study and remember before an exam, it's nice to be able to leave a few off the list, because all we have to do is memorize the concept that the bottom of the rectangular prism is a rectangle, and if we take the area of that rectangle, the length times W, and multiply it by the height, we are just finding how many red rectangles would fill up the box, and therefore we are finding the volume.